Alright guys, so here is where we left off in SI. We didn't quite do this part, I just kind of told you what to do there, but when we were in SI, the last thing we actually got to was balancing the equations, writing and balancing the equations. And you need to do this so you can find the molar ratio between each of these and water. Because eventually you want to get to the milliliters of water that should be produced, theoretically. And we'll be using the density to do that. But these are your given volumes of each. So we'll take those volumes, multiply them by the density. That'll give us the grams. And then we'll divide it by the molar mass to get the moles. Use the molar ratio to find out how many moles of water we have. Then use the molar mass of water right there to find out how many grams of water we have, and then use the density to find out how many milliliters. You can tell since it's 1 here, whatever we have in grams, we're going to have in milliliters, but I'll write that step in just to be completely thorough, completely clear with everything. Okay, so let's scroll up just enough to see that. We were given that we had 229.75 milliliters of hexane. So let's go ahead and turn that into grams. So for that, we're going to use this number right here, your density, 0.659 grams per milliliter, and that's for hexane. So now we'll have grams of hexane once we do this computation, and from that we will use this carry here, our molar mass, to get moles. So 86.178 grams of hexane gives us 1 mole of hexane. I'm just going to write hex for now. Now we're going to use the mole-to-mole ratio, or the molar ratio, however you prefer to say it. So this is hexane right here. So it's 2 moles of that will give us 14 moles of water. So 2 moles hexane, 14 moles of H2O, and then we'll use the molar mass. 18, or whoops, my bad. Started writing that in the wrong place. 18.015 grams of H2O in 1 mole of H2O times, and then like I said, it's just a 1. So 1 gram of H2O gives us a milliliter of H2O. Okay, so really quick checking to make sure units cancel. Milliliters of hexane, milliliters, grams of hexane, grams, moles of hexane, moles, moles of H2O, moles, grams of H2O, grams. We're left with just milliliters. Cool, perfect. So we have, when you do that math, you get 221.5526 milliliters. For sig figs, since this only has 3 sig figs, you would technically stop right there. So if this was the end of the question, 222 milliliters of H2O is what you would have, because you would round up from that 5. So that's the first amount that we have. Once we get all of the amounts that we have, we're going to add them together to get our total or theoretical amount. And then we're going to use this formula right here. It's percent yield equals actual divided by theoretical times 100. So it's the stuff right here in the pink. All I did was show you like the quick algebra to rearrange it to find out what our actual yield is going to be. So divide by 100 times by theoretical. That gets rid of those. That moves everything over here. So your actual yield is going to be your percent yield divided by 100%. That'll cancel your percentages, the unit percent. And then you'll multiply the theoretical yield by that number, and that'll give you our actual yield in milliliters. Okay, so let's go ahead and put that number right here, 221.5526. And let's figure out the next one. Okay, so we were given that we started with 927.38 milliliters of octane. So multiply by the density, which is above on that table. It is 0.703 grams of octane for every milliliter. And then 1 mole of octane, and this is from the graph above. Gosh dang it. Scroll up. Okay, so that's where I got the density from. That's where I'm going to pull the molar mass from. 1 mole of octane is 114.232 grams of octane times, for every 2 moles of octane, that's oh, you can tell where I'm getting the formulas from. When you're doing stuff in the future, though, like in hexane, in octane, you're supposed to know those. But that's the future. That's why I gave them to you now. Anyways, so we're at moles of octane. So for every 2 moles of octane, we get 18 moles of H2O. And then you'll notice the last 2 steps, these guys right here, are going to be the same for all 3 that we do right now. So 18.015 grams of H2O, 1 mole of H2O, and then milliliter, 1 gram of H2O. And that's the density right here, and this is the molar mass. So quick check to make sure our units cancel. This is a really good practice to get into. So milliliters, milliliters, grams, grams, moles, moles, moles of H2O, grams of H2O, and we're left with milliliters. So that equals, when you do the math, 924.60495 milliliters of H2O. So I'm going to go ahead and add that to the list that I have above. If this would scroll, please and thank you. 924.60495. Sorry, my dog just came into the room. So if you guys heard his footprint or his little paws, that's why I got quiet for a second. Okay, anyways, sorry. So you start with 379.24 milliliters of benzene. This is what benzene looks like when you draw the skeletal structure of it. And you'll get used to this stuff as you see it more often. We're going to multiply by the density so we can get it into grams, something that's more useful to us. 0.879 grams of benzene. Sorry for the horrible skeletal drawing. Per milliliter. And this is from the table, like I said before, but I'll scroll up and show you. I also put a copy of just this question itself on the Google Drive, and the key itself is on the Google Drive as well. So if you want to print it out, or if you have a copy of it with you, if you came to SI, then you can just follow along on that. But okay, so 1 mole of benzene is 114.323 grams of benzene. And just like I said, just to show you guys, that's from here. Whoa, I did some wrong math. That sucks. Okay. So 78.115 is what I should have. And okay. Can't believe I didn't catch that. Okay, so 78.115 grams, and then looking back at our equation, our balanced equation, 2 moles of benzene will give us 6 moles of water. And then 18.015 grams of water is 1 mole of water. And then, again, 1 gram of water per milliliter. Okay, so give me like 2 seconds so I can do the math again. Oh my god, I think I might need a new pen. Okay, so 379.24 times 0.879 divided by 78.115 times 3. And the 3 comes from the 6/2. And then times 18.015. And then times 1, you don't really need to do that. But that gives you 230.63. This is our last significant figure. 6344 milliliters of H2O. Okay, so we need to add these 3 together. So I'm going to go ahead and do that down there because up there it was looking pretty cluttered. Okay, so it's going to be 221.5526 milliliters plus 924.60495 milliliters plus 230.6344 milliliters. And remember, all of these technically would stop right here, so I'll just underline that. But we're going to carry this all the way through to get the best answer possible. So that number plus 924.605 plus 221.5526 equals, I get 1376.791957 milliliters, and our sig figs would stop right here. Remember, when you're adding with sig figs, whatever your furthest decimal or your smallest decimal place is, that's significant, that's where you would like draw this imaginary line, and whatever's to the left of that would be your last significant digit. So with this number, we're going to use, scroll up. We're going to use this formula right here that I rewrote. So actual is equal to the percent yield divided by 100% times our theoretical yield. And what we just found out was our theoretical yield. So we can do this part of the math super quick. 97.6 divided by 100 is going to be 0.976. So this number times 0.976 is going to give us our actual actual yield, and that's going to be in milliliters. So take that number times 0.976 equals 1,343.74895. This number right here only has 3 sig figs. So your final answer in milliliters is 1340 milliliters of H2O. If you look at the key I just posted, it has the wrong answer because I used the wrong molar mass. I will change that right now. But yeah, that's how you would solve that one. Like I said in the blog post, if you look at that, this is like a combination of anywhere from like 4 to possibly even 10 problems. So like, don't worry if you're like, I have no idea how to solve this whole thing. This is just the easiest way I can make the most out of that hour that we have, just so you guys can actually cover a wide range of topics in such a ridiculously short amount of time. But anyways, thank you guys for taking the time to watch this. I hope this helped. Let me know if you have any questions. I'll post the link on the blog. I'll post the link on Remind, and I'll also send out, so you'll have 2 reminders in a minute, and there'll be the blog, and there's a couple people that still don't have the link to actually get to the website. So one will be straight to the blog, one will be to the website. All right, again, thank you so much for watching, and I look forward to seeing you tomorrow. And yeah, let me know if you have questions. Okay, thanks. Bye.